step is to use momentum conservation, right? So initially, you just have, so I'll use the subscript C to denote sports car and S to denote SUV, okay? So initially, you have the sports car as the only thing that's moving. So mc times vc is the initial momentum. And right after collision, they stick together. And so the masses are added up, mc plus ms times v prime of velocity after collision, okay? And so vc, the velocity with which the speed with which the sports car was moving is what we want. And so that it will be mc plus ms over mc times v prime, okay? And we'll call that our equation 1. And so in part 2, we're using energy conservation. And so here, we're noting that the kinetic energy that's the change in kinetic energy, or the kinetic energy that's gained by the cars right after the impact is directly from the work done by friction. Okay, so kinetic energy is equal to work done by friction, and so kinetic energy, as we know, is 1/2 times m, which would be the combined masses mc plus ms, times v squared. This would be v prime squared because it's the velocity after impact, and that is equal to work done by friction. And work done by friction, remember, is force from friction times the distance traveled. So delta x is what we're calling that. Force of friction is mu k, coefficient of kinetic friction, times normal force n, which is equal to mg, the weight in this case. So this would and this would be a negative, by the way, negative over here. And I also forgot to mention that this is a change in kinetic energy, so that it changes from 0 in the final stage from this value, the initial stage. So it'll be 0 minus this. Okay, so that is equal to minus mu sub k times mc plus ms. That's mg. Okay, mg and m is the two is the combined masses. Times g times delta s. And so what we have here is 1/2 times the sum of the masses, v prime squared, is equal to mu k times the sum of the masses, times g times delta x. mc plus ms cancel out, and we get that v prime, or v prime squared, is equal to mu k times 2 times g times delta x. In other words, v prime is the square root of 2g delta x mu k. All right, and so finally, step 3, plug v prime into equation 1. And so equation 1 is just vc, which is what we're after, the initial velocity of a sports car. And that is equal to mc plus ms over mc times v prime, which is square root of 2g delta x mu sub k. All right, and so now we're just plugging in values. Sports cars, mass is 920. SUVs is 2300 over 920 times square root of 2 times 9.8 times 0.8 is 2.8 meters. 2.8 meters times 0.8, which is the coefficient of friction. 9.8 is meters per second squared, and the kilograms cancel there. And so what we get is 23.2 meters per second is how fast the sports car was going initially.